Morning or afternoon.
Yeah, it's already. I will start in a couple of minutes. Let's see if somebody else is joining. We can start in a couple. Meanwhile, people are joining. Do you have any questions? So we will continue with the discussion what we are having on the system design integration. So anybody has any questions based on the previous sessions what we had? Happy to answer
Hi,
those.
Asma. Hi, Asma.
Yes, indeed.
I have a question. So I saw one of the DE fundamentals videos where you explained where Ninad explained about the Nike architecture. So in
So
Nike
we,
architecture, they use Glue
yeah.
as a ETL process.
Uh-huh.
In the architecture that Ninad explained in the previous session, he suggested that they use Kinesis and Firehose to ingest the data. So, but in Nike architecture, they're using Glue. So, how can we understand when can we use Glue or when we can use Kinesis or Firehose? That's what I'm confused because like
Yeah.
RDBMS source is common in both the architecture, but in Nike architecture there is Glue. I mean, in Arts architecture there is another like Firehose and Kinesis and Firehose. So, which one to choose?
Yeah, that's a good question. Can we bring up, so how do we decide that what we have to use? And that's all purely based on your use case, right? If your use case is to process the data at a certain interval, right? You go about using the services, what works for that particular use case, right? And if your use case is to process the data as soon as it gets generated, then probably the services what you use could be a different. Okay, so let me brought out a diagram what we have, and this is a kind of a reference architecture what we call in terms of designing any architecture for any organization, right? Of any use case. So any architecture which we are trying to build for an organization, it should cover every aspect of your data engineering. Right? It should not be that okay, because in an organization you could have multiple teams working on different problems, correct? So there could be teams who has data coming from, let's say, web API or some IT services. There are some teams who are consuming the data from OLTP systems. There are some teams who are consuming the data from more traditional data sources like SQL Server, Oracle, and all that. Correct? So you need to have a reference architecture for all these data sources in an organization, so that everybody's requirement is catered to build the data pipelines, right? So your question was that okay, Nike, but we have used a glue job, right? But in somewhere we are talking about a real time where we are using the Kinesis files and all that, right? So if you see, you divide, you use the services based on your data source requirement, right? Like, okay, what type of data sources you have and how the data is being generated at the source, right? Um, uh, let's say in an ID case, so all the stores are collecting the data for an entire day, right? Like somebody is purchasing, somebody is purchasing some shoes and all that, right? And you have multiple Nike sources across a different region, right? And everybody is putting their data to their system based on the purchase of the customers, right? And that data is going to a more SQL Server Oracle kind of a database on the backend, right? There is no need for that to be consumed into a data warehouse where you want to do a reporting, right? Because your reporting is not based on a real time basis, right? You don't want to understand that, okay, how much sales my this particular store has done on a previous hours, right, or 2 hours back, right? What in that terms, what we do is like, okay, what was the sale on a particular quarter, or what is the sales on a particular month, right? And how this particular store is more profitable compared to the store which is in X area compared to the store which is in the Y area, right? So there is no need of a business requirement where you have to do a real-time reporting on that, right? So your requirement is that, okay, you collect all the data throughout the day for all these different stores of Nike you have, and then process the data once in a day to your data warehouse. Okay, so in that aspect, there is no point of using Kinesis, Firehose, and API Gateway or Kafka, whatever the streaming technologies you have, right? Because your data warehouse processing and everything is happening once in a day, right? So in that sense, what we use Glue, right? Because Glue is more of a batch processing tool, okay? Where what it is going to do, it's going to consume the data from these different servers once in a day, and then push the data to your data warehouse, okay? And there in your data warehouse, then you can do all sort of transformation on the data and then generate the report for your business use case. Okay, but if let's say if the use case where you have a app which you have built for your company, right? And in that app, you want to understand that, okay, how the customers are engaging with your particular app or your particular website, right? So and that particular analysis is being happening on the real time basis, right? So in that scenario, you could ingest the data from those particular sources on a real time basis, where you can use Kinesis, Firehose, and API Gateway, and the data will flow to your data warehouse on a real time basis, and then you can perform the analytics on top of that, right? So that in any new offer or any new things which you want to apply to your website or app, you can quickly do that based on the engagement of the customers, right? So depending on your use case, what you're trying to solve, your services will change according to that. Make sense?
Yes, sir. Thanks for answering.
Okay. Any other questions? Should we continue with the?
So Glue is it built on Kafka or is it built on Spark? How can we share?
Yeah, so Glue is a service, right? Which entirely use PySpark engine, right? So it uses a Spark engine, okay, where you can write a PySpark code. It's not built on the Kafka, okay, but the underlying servers and everything is kind of a Spark engine what you have. Okay. Yeah, so let's go about discussing what we have here. So we are talking about the system design, right? And in the system design, there are a couple of things which we need to take care of that. Okay, so one thing is the first and foremost thing is the scalability aspect of your design, right? So scalability is nothing but how effective your solution is to scale up to a business requirement, which is probably going to come into the future, right? So any data pipelines which you are building, right? It should be scaled enough. It should be scalable enough to accommodate any business requirements what we have. So let's take an example that, okay, you created a website for your use case, right? And currently the traffic on that website is let's say 100 customers per day or 1,000 customers per day. Okay, so you probably could have choose a service on the back end where you are ingesting the data from that particular website in a manner that, okay, the services what you have chosen on the back end is, let's say, in AWS Lambda. Okay, and from Lambda you're ingesting to an S3 bucket, and from S3 bucket, let's say, as a data warehouse, what you have used is let's say a SQL Server or Oracle. Okay, because you understand that, okay, the traffic on my website is currently 1,000 user or 100 user per day. Okay. So with that much of capacity, your backend system, what you have built, which is like Lambda, S3, and let's say SQL Server Oracle, should be able to handle your load of the data processing, right? Because the number of user on your website is pretty low at this point of time. Let's say suddenly the traffic has increased from 1,000 customer per day to, let's say a million customer, let's say 100K customers per day. Okay. With that much volume, the current infrastructure what you have built on the backend side will not be able to support that, right? Because there are some limitation on Lambda, which is it only goes 1,000 instances per second, right? Then there is a constraint on your SQL Server Oracle, which you have used as a data warehouse where you're trying to perform the analytics, right? So with the sudden increase on your volume of your data, the current infrastructure what you have built is not scalable enough. Okay, that's why the first and foremost feature what we choose when we are designing a system architecture is how much scalable my current solution is going to be, that right? And you have to predict that, okay, today I have 1,000 customers on my website, tomorrow it could grow to 100K or 10K, whatever that number is, right? So you need to choose the services which you are using to process the data based on those factors. Okay. So, in that case, that okay, you need to choose that, okay, what all services I can use to ingest the data from my website, which is going to automatically scale as soon as my the traffic increase on my website, correct? And then you also have to choose that, okay, what type of database I have you choose. It could be a SQL Server, NoSQL Server, right? It could be a cloud data warehouse where the storage is not an issue, right? Because in SQL Server Oracle, if your data gets increased and you have to increase the size of your warehouse, then you have to entirely shut down your application and then increase the server size and all that, right? But in cloud infrastructure, you don't have to bring down your application. You can just on a click of button, you can increase the size of your data warehouse. Okay, so all these factors needs to be considered when you're designing a system for your application or for your organization. Okay. So that's the scalability factor of it. Now, there are two types of scalability what we have to consider. One is the horizontal scaling and another one is the vertical scaling. Okay. So what is horizontal scaling is that, okay, so you have a current infrastructure where you want to just increase the size of that particular infrastructure, right? So so you guys are working with Snowflake, right? So there's a concept of warehouse in Snowflake. Okay, so when if you have seen those warehouse, there is a size defined on those warehouse, right? So it starts from extra small and it goes to 6x large. Okay, so those are the size of your warehouse. So it goes extra small, medium, large. So the extra small warehouse will have only one core, right? The CPU, the GPU is only one. Okay, when you go from extra small to medium, you will have two servers, two GPUs, two CPUs, and all that, right? So your capacity will increase, your the processing power of that particular warehouse will increase as soon as you increase the size of that particular what do you say warehouse. Okay, so that's a vertical scaling, that you are increasing the size of that particular warehouse. There is another horizontal scaling. So horizontal scaling is nothing but you are adding more servers to your cluster. Okay, so there is a cluster on Snowflake where you have one server as of now, which is where you are processing all your data. Now tomorrow, if you need more number of there are more number of people who are concurrently accessing the Snowflake environment, then you have to add more server to that particular infrastructure, right? So you are scaling horizontally. Okay, so now let's take an example of what these use cases and where you can use vertical scaling and where you can use horizontal scaling. So in terms of vertical scaling, in terms of horizontal scaling in Snowflake, let's take an example of there is a e-commerce company who is using Snowflake to analyze your customer data across different regions, right? And there could be a peak hours where multiple customers are accessing the same Snowflake instances, right? So let's say from morning 10 to afternoon 2 p.m. There are 1,000 customers who are accessing the same Snowflake environment where they are accessing the data from the databases and all that. Okay, and doing some analysis on top of that data. Okay, so that's a peak hour. Now, at that point of time, your infrastructure should be scalable enough to handle all those 1,000 customers who are trying to access the Snowflake. Okay, so what you can do, you can horizontally scale your infrastructure at that point of time, right? So you can add more servers to your infrastructure so that it will accommodate all those 1,000 customers who are trying to access your Snowflake environment. Okay. And as soon as your number of customer goes down after 2 p.m., you can just remove those servers out of your infrastructure. Okay, and this is all automatically done by your Snowflake, right? If you define your infrastructure such a way that you create a multi-cluster warehouse where you can define that, okay, the minimum servers what I need is 1, and the maximum servers what I need is 10, right? So as soon as Snowflake understand that, okay, there are more traffic which is coming to my platform, where the number of customers has increased from, let's say, 100 in the morning to 10,000 in the afternoon, right? So what Snowflake will do, it automatically start adding new servers to that cluster, right? So it can maximum go to 10 servers. It can add to a single cluster. Okay, and the size of the cluster could be a extra small, medium, large, whatever you have defined while creating that infrastructure, right? So that at that point of time, your Snowflake will be is able to handle all the requests coming from those 1,000 customers. Okay, and as soon as the people start getting logged out of Snowflake after 2 p.m., the Snowflake will keep on removing the servers out of that cluster, right? So that your cost is not increasing. So right. So this is the one requirement where you want to horizontally scale, right? Based on the number of concurrent user on your platform, you are just keep on adding your new servers to your platform. Okay. The other one is your scaling, vertical scaling. Okay. So vertical scaling, when do you use that? Okay. So there is a financial analytics firms who is using Snowflake to do a daily risk assessment, right? And whatever assessment they are running, that's a very high computational power process which they are running, right? So the queries what they are running or the data which they are trying to process is too much. Okay. So in that particular requirement, the current infrastructure what you have is not able to handle the requirement, right? Because the queries are running longer and it is keep on spooling out, right? Because you don't have a sufficient memory in your servers to accommodate that particular process. Okay. So at that point of time, you don't have to add more server to your infrastructure, right? What you have to do, you have to add more CPUs and GPUs to the current infrastructure what you have, right? So keep CPUs and GPUs are nothing but your processing power. Okay. So let's say you are currently using a medium-sized warehouse, which has like 2 servers, 2 GPUs, and 2 CPUs. And at that point of time, when you're running these risk assessments, that particular server is not able to handle the request what you're trying to process. Okay, so what it does, you just increase the size of your warehouse, right? So you probably increase from medium to, let's say, extra large warehouse. So in extra large warehouse, you could get 16 CPUs and 16 GPUs, right? So your processing power has increased on that particular server, which is your vertical scaling. You are increasing the power of that particular server. Okay, and then at that point of time, you run your process, you run your assessment, and then scale down from your extra large to medium warehouse, which was previously what you have configured, right? So 2 aspects of your scaling. One is horizontal scaling, where you are keep on adding new servers to your infrastructure, right? Based on the number of user suddenly increase on your infrastructure, right? Another is vertical scaling, where you are just increasing the processing power of the same servers what you have, where you add more CPUs and more GPUs into the infrastructure to process a high intensive computational query or large volume of data. Cassie, go ahead. You have a question?
Yes, yeah. So basically, what is an example can you give for this high computational risk assessment? How
Yeah, so
does it
high
look like?
competition, yeah. So how competition looks like, okay, basically in a normal scenario, you are only processing, let's say, 10 GB of data, okay, which is your whatever current infrastructure what you have is easily able to handle that particular request, right? It's able to access those 10 GB of data and able to process whatever transformation you are running, right? Suddenly, let's say there, so that's our data engineering process, let's say you are running, okay, so that is able to process that 10 GB of data. Suddenly there is a process which is involved in let's say a data science project, okay, where you have to run your model on top of, let's say, one terabyte of data, which is the volume of data has increased. And in your model, you probably have to use different libraries, different models to see which model is going to work better. Okay, so at that, and for that particular process, the current warehouse what you have, which is a medium, is not going to be able to handle it. Okay, it will process the data, but it is going to take, let's say, 1 hour or 2 hours, which you don't have, right? But you could quickly want to process the data within let's say, minutes or within the minutes, right? So what you do, you increase the size of that particular warehouse. Okay, so you increase from medium to, let's say, extra large. Okay, so when you increase the size of the warehouse, what you are doing in terms that you are adding more resources to that particular infrastructure. Resources in math, you are adding more memories, more CPUs, more GPUs. Okay, so when the processing power increase, the same process of data science projects which you are running, where you are processing 1 terabyte of data, and which previously was only able to complete within 1 hour or 2 hours of that, it will be it should be complete within the minutes, right? Because you have increased the size of your warehouse, right? So that's the one example what you can take it, that where you can increase the size of your warehouse. Hopefully that answers your question, Singh.
Yeah, thank you.
Azmat, I have a question. So both scaling happens automatically, both vertical and horizontal. How exactly does it work?
Yeah. So in Snowflake, you can configure it automatically, right? So that's what I said that, okay, because Snowflake is a multi-cluster warehouse, okay, where based on your current requirement, Snowflake will automatically scale out or scale up. Okay, let's say Snowflake sense that, okay, there are more number of user who is trying to access your Snowflake account, okay, and the queries are going into queue, okay. So what it does, it start adding resources to your current infrastructure, okay, so that the queries will so there is one server where all the queries are going, and they keep on going in the queues, right? Because until unless one query is finished, the another query is not going to start, okay. What it does, it start adding new servers on that, right? So as soon as Snowflake adds the server, the queries will move from the first servers to second server, right? And if still Snowflake thinks that, okay, yeah, adding one more server is not helping because more number of queries are coming into it, so then it will start add another server, right? So it will keep on adding the servers based on the performance of the platform, okay? And so maximum, yeah.
There's a maximum, right? I mean, there's on a vertical scaling, a server can have a certain limit, right?
Yep.
So
So that's what
if
I'm
it
saying,
goes
right?
beyond the limit,
So yeah, the 10 is the maximum where you can have the cluster. Okay, so from 1 to 10. Okay, but if it goes beyond that, then yeah, it will keep on trying that, right? Because there is always a limit, right? You cannot beyond that. Okay, so that's the limit what Snowflake has, is that you can scale up till the 10 server. You can add it 10 clusters you can have at a single point of time, right? But because of the resources and what we have in Snowflake, it should be able to handle it. Okay, so all these things, sorry.
As a developer, you're supposed to know, you are supposed to have a good estimate as a number of maximum resources that you're going to consume.
No,
right?
as a developer, you should understand that, okay, what sort of process you are trying to put into the place. Okay, it's not your domain that you go and configure those servers, right? Or increase the size of your warehouse and all that. Okay, it's always going to be the admin who is supporting the Snowflake environment. Okay, but it's the developer who is going to give an information that, hey, this is the current application what I have, which I was able to run, let's say on the media warehouse couple of days back, right? Now suddenly my data volume has increased, right? So the current infrastructure what I have, which is running on the media warehouse, is not able to accommodate, right? Because there is always a SLA defined on any of the processes what you are building, right? Because the end user is the business, right? And business is going to put an SLA that, okay, within 1 hour, 2 hours, or once in a day, I should have the data into my dashboard and whatever application I'm using. Okay. So if your SLA is not is getting completed within the time which the business has defined, then what you can do, you go back and talk to the admins who is supporting the platform. That, okay, hey, the current requirement which I have is not able to fulfill within that medium warehouse. Can we increase the size of the medium from medium to, let's say, large warehouse? Okay, so that we can meet the SLAs. Okay, so based on your current assessment of the processing what you're doing or the data volume you're going to expect, you go back and talk to the team who is supporting the Snowflake, and they will increase the size of the warehouse or scale up or scale down based on your requirement, right? But it is a team who's running the pipelines, who's building the pipeline, is the those team is going to give that information to the team who's going to increase the size. Make sense?
Thank you.
Anybody? Yeah, you have raised your hand.
Hey Asmat, so
Yeah.
in the horizontal scaling, you said that when more users are trying to access the server, the Snowflake will be automatically creating more cluster and adding server to it cluster itself, right?
Yeah. Yep.
So you have the infrastructure. The creation of the cluster will be automated, or you have to manually do it, or
Yeah, so that's an automated process, right? So so your cluster will always be defined, okay, Abid, right? So when you create a Snowflake instance for your organization, right? What you can do, you can either create a single cluster warehouse, okay, or you can create a multi-cluster warehouse. So if you are creating a single cluster warehouse, this horizontal scaling is not going to work, because that's the only one cluster which what you have, okay. The Snowflake will not be able to add more servers to that particular cluster, right? But if you are creating a multi-cluster warehouse, right? So any organization who works on Snowflake, they always create a multi-cluster warehouse, okay? So in multi-cluster warehouse, you will define a threshold that, okay, the minimum is going to be 1 cluster and the maximum is going to be 10 clusters. Okay. So as soon as your requirement change, your concurrency increase, where you have more number of people onboarding to Snowflake, and the current process is not able to handle all the queries which are coming from these customers, right? So what it does is Snowflake will automatically start adding one cluster to your infrastructure, okay? Because you can go up to 10 clusters, okay, where you can add 10 clusters, and those clusters will have, like, they will have servers, they will have CPUs, and they will have GPUs. Okay, so it will keep on adding to your cluster, and that is automatically done by Snowflake. You don't have to manually go and add them.
So that is a part of the horizontal scaling, where keep on adding more cluster, and in each of the cluster, Snowflake will be creating the servers to handle the large volume of data or users.
Yes,
right?
Yep. And in the horizontal scaling, the size of your cluster is going to be the same, right? So if you have defined a medium size, so all the cluster what you're adding is going to be of the same size.
Some size, okay.
Okay.
And in the do you mind explaining the part where you are increasing the CPU and GPU in the vertical scaling? How is it done?
Yeah, so this is what happens, that you increase the size of your warehouse, right? So if you see in Snowflake, right, there is a on the right hand side top, if you see, there's a warehouse which you have created, like compute_warehouse, right, or whatever warehouse you have created, right? In front of that, you see there is a size defined to that warehouse. right? So there could be extra small, there could be small, there is a medium, there is an extra large. It goes to 6x large. Okay, so
Okay.
that's a t-shirt sizing what Snowflake has done. Okay, so now in
Okay.
that extra small warehouse, you would have one server, okay, one CPU and one GPU. Okay,
Okay.
and as soon as you increase the size from extra small to small, you could have two servers, two GPUs, and two CPUs. Okay, so in the multiplication of two, as soon as you increase the size, your servers, your CPUs and GPUs are going to increase. Okay,
Increase.
now
Okay.
yeah, so that's your processing power, right? So what you can do, you can automatically increase the size of your warehouse, right? Like if you have a trial account, you can just write a SQL statement where you can just alter your warehouse and make the size from, let's say, extra small to large. Okay. So how you do that? Like let's take an example that, okay, you're running a query on a extra small warehouse, right? And that query is taking, let's say, 1 minute to process the data. Okay. Now, when you increase the size from extra small to, let's say, medium, and you could instantly see the difference of the execution time. That execution time might change from a 1 minute to, let's say, 10 seconds, because what you have done, you have increased the resources into that particular warehouse where you have now two servers, two GPUs, and two CPUs, right? So when it has more resource, it will be able to quickly go back to your database, figure out what all data you need to process with that query, and give you that result, right? So that's your vertical scaling.
Okay.
Make sense?
Do we have any example of this in the academy?
Yeah, so horizontal scaling we cannot, right? But vertical scaling we I think currently we don't have, but we can put that, right? And you can also do that, Abid, right? Like just go to your Snowflake account, right? And pick a warehouse which is, let's say, a compute warehouse what you currently have, and check the size of that warehouse. Okay, if the size of a warehouse is extra small, try to run a query and see what is time it is taking. Okay, and then again, what you can do, you can just go and change the size of that particular that warehouse from extra small to, let's say, medium or large, right? And run the same query and see the difference on the execution time. So what if in that previous query it is running in 1 minute, it probably come down to in few seconds and give you a result, right? So that's the vertical scaling what.
So, Asnath, as a data engineering perspective, right? I mean, to scale up and down the Snowflake cluster or to create more cluster, is that done by data engineers, or is it something we have to request to the admin team and they will be doing that from the backend?
Yeah, so this is always a request to the team who is supporting there, right? Because like you could have like 10 data engineers working in a project, right? And you don't want to give an access to everybody to go and work with that platform, right? Do any changes to the platform, right? Because there is a data which is there in the platform. There are multiple customers who is trying to access the particular application, right? If somebody did something wrong, your entire application will go down, correct? So it is always a data engineer who is going to request to the team who is supporting this particular platform, right? So you could have multiple platforms into your organization, right? So, and there will always be a team who is going to support the platform, right? So there could be a AWS platform team, there could be a Snowflake platform team, there could be a DBT platform team, right? And you as a data engineer is going to use all these platforms, right? So based on your request, your requirement, any change in the requirement, if you want to configure something on your platform, you always have to go back and ask the platform team who is supporting that particular platform to make a change into that. Okay. But yeah, let's say you work with an organization where you don't have too many people, right? It's only you as a data engineer and you are only supporting that platform, right? So it's your responsibility to go and make the change in the platform, right? So it's all depend on what is the setup which is done into that particular organization. Okay, and based on that, you take it forward.
Okay. All right. Thank you.
No worries. Shilpi, you have a question. You have raised your hand.
Yeah, I somehow can't understand how is it that when you increase the storage, like vertical scaling is equal to increasing the storage, and that would reduce the query time. like the
Yeah, it's
response
not
time?
it's not a storage. It's just that you want to add the processing power to your servers. Okay. So let's say
Okay.
you take an example of your laptop, right? You have a RAM of let's say i5. Okay.
Oh, okay.
Currently we have i7 and i9 also, right? So if you're running an application on an i5 system, it might run slow, right? Because it does not have RAMs, it does not have ROM and all that, right? Similar to that, it works in the same analogy over here, right? So what you are doing, like, okay, currently you have an i5 system, now you are increasing to i7 because your application is too large to run on i5, right? If there is another application which is not running on i7, you probably change your laptop from i7 to i9, correct? Then the application will run, right? So what you are doing, you are adding more RAMs to your laptop by changing the i5 to i7 to i9. Similar happens into your Snowflake, right? So you have a small warehouse, which let's take an example that's an i5. Okay, so the current data engineering process which you are running, the data volume what you have is not able to handle with the extra small warehouse, right? So you have to increase your size of your warehouse. When you increase the size of the warehouse, what you're doing, you're adding more CPUs, more GPUs, more processing power to that particular server. Okay, so that your queries will run faster, because if you have more resources, your queries will run faster, correct? So that's how your vertical scaling of your resources. So that
Okay,
your
so it's not like Dropbox where I have 1 TB data and then I
no.
buy
Yeah,
more
data.
and then it becomes 2 TB. So this is
No,
like
no.
more of like RAM,
Yes. So
2x,
in
3x,
Snowflake,
4x.
yeah, Snowflake has the processing power and the storage are decoupled. It does not
Oh,
work in the
okay.
same, right? So you have a separate storage where you can like what you said, that okay, you can purchase more storage, where you can increase the storage from 1 TB to 2 TB, right? Where you can store more data, right? Then another is your computational power of your Snowflake, where you are increasing the size of a warehouse, where the Snowflake will add more CPUs and GPUs to your server, and that will run your queries faster.
Yeah, okay. So and how is it like, so the horizontal scaling means that, like, define the cluster, because I am able to understand that, okay, if there are multiple users, to each user, if you assign separate, processing power, then for each of them, the performance is good. Like, it doesn't go down.
Yeah.
But how does that, like, somehow I'm not able to, like,
No, so I'm
conceptualize it in my mind.
Yeah, so
What cluster?
let's say there is a organization currently, they have only 10 customers who are accessing your Snowflake platform. Okay, now that cluster what you have built is like having one server, and that server will have whatever resources that cluster will have. It is able to accommodate 10 users, 10 customers what you have. When they are running the queries, they are able to get the answers very quickly, like within seconds. They are able to get the answers. Okay, so now suddenly the number of customer has increased from 10 to 1000, 100. Okay, now all those 100 customers are running the queries on the same platform. Okay, so you only have one server where you might getting a request from all these 100 customers, and what is happening here, because it's a one server, one queries will run at a time. Okay, then what is happening, all the queries are going in the queue, right? So previously, within the seconds, you are able to get the answers. Now that same queries are running longer, which is like 1 minute or something. Okay, because there are more number of users who is trying to access the platform, and they are sending more requests or more queries to a Snowflake environment. Okay, so there is only one server. Now what Snowflake will do, it will add one more server. Okay, so now what happens? All the queries which are in the queue, it is going to get diverted from one server to another server. Okay, so it will somehow reduce the amount of time which is taking to run the same query in one server compared to the two servers. Okay, so if your need is if your need is like if your, so there is a threshold which Snowflake has defined that okay, within let's say 10 seconds, if your queries are not running and you have, let's say I'm just giving a hypothetical situation that okay, within 10 seconds your queries is not moving from queue to processing, and you have 10 more queries which are in the queue, then Snowflake will add a server. Okay, so there is a mechanism through which the Snowflake will try to understand that okay, with the current infrastructure, whether I'm able to execute all the queries which are in the queue. If not, then I will add another server to my cluster. Okay, so that the queries which are in the queue on one server, it will move to the second server, and they will keep on running. Right. If the second server is also not able to handle the particular situation, then it will add another server. Okay, so that's how it will keep on adding the servers to your infrastructure, so that the queries will run faster. They are not in the queue. Okay, and as soon as it understands that okay, the number of queries in the queues has been reduced, it will keep on removing the servers from your infrastructure.
Okay, so now what I understand is like the difference between vertical scaling and horizontal scaling is that like the horizontal scaling follows the traffic, like when it's peak, then there'll be more servers assigned, and the vertical scaling is based on the average traffic or like average.
Not average traffic. If you want to process a large volume of data, okay, if you need a more computational power, right? You are running. You have 100 customers who are running the queries, but those queries are very small queries, which Snowflake is able to handle, right? So if there is a concurrency in the place, then it is horizontal scaling, okay, because you have increased the number of customers who is accessing, right? But the same customer who is trying to access 1 terabyte of data, right? And the queries are not able to run within the infrastructure what Snowflake is defined. Then at that point of time, you have to scale up, which is vertical scaling, where you are increasing the size of your warehouse, where you are adding more CPUs and more GPUs, so that 1 terabyte of data is processed quickly. Make sense?
Yeah. So like the horizontal scaling is more of parallel processing, and it depends on the peak, the traffic, like user traffic.
Yeah.
If it's low, then there have be lesser cluster. Okay.
Yep.
And is there also the design of the vertical scaling is also such that like, is it that it goes up and down, or it's more of a static depending on the volume of data and the query, the complexity of the query?
Yeah, so normally what we do is like we don't do that automatically. You can do that automatically with some process on Snowflake, right? But typically what we have to see is that okay, we don't allow it to happen vertical scaling automatically, right? Because there is always a cost associated with the queries what you are running. Okay, so the same query, which is because when the Snowflake when you run a query, it is whether it runs for 5 minutes, 5 seconds, or 10 seconds, is always going to be charged for entire 60 seconds. Okay, so that's why we don't want to, let's say, for a medium warehouse, your queries runs in, let's say, 45 seconds. Okay, so which is fine when it charges for 60 seconds, right? But what it does is, if you are automatically scaling up from, let's say, a medium warehouse to a large warehouse, and your query runs within 10 seconds, okay, in that scenario also, you're going to charge for 60 seconds, right? So in both the scenarios, your charge is going to be the same, right? And that's why we don't allow it to automatically vertically scale up, right? Because then the cost will increase, right? Your queries will run faster, but the cost is going to be increased, right? So the vertical scaling always happens where you go and talk to the team who's maintaining the platform to request that, okay, hey, the current pipelines which I'm running is not able to process my data. Let's say there is a historical load suddenly you want to do, right? Which is going to consist of 3 years of data, right? Then what you can do, you can just go and talk to the team saying that okay, for a one time, what you can do, can you just increase the size of my warehouse so that I can process this 3 years of data, and then you can vertically, then you can scale down that from large to medium warehouse, right? So that's how you can do it. By talking to the team who is supporting the platform. But we don't allow automatically to happen the vertical scaling.
Okay, so this is mostly based on like cost, optimizing the cost.
Correct.
Vertical scaling. And it's way more costly than the horizontal scaling. Like that the
Yeah.
cost associated with horizontal scaling can be like stepwise, it's lesser increment rather than the vertical
Yeah.
scaling is like higher. Okay, great, makes sense. Thank you.
So I have a question.
Yeah.
So doing this, what are the consequences of the fault tolerance? Like because so many queries are inline, right? The horizontal scaling. Then does it affect that the query can drop, or what is the fault tolerance? And
Yeah. So I think so we have seen into the like legacy systems, right? Like I'm not sure if you guys have seen it, like in Teradata and all that. When you run a query, right, there is always a spool space assigned to that particular like the user who is running the query, right? So that spool space is nothing but a temporary space where you access the data from your database where the data is stored and then do the processing in that particular space, right? So that spool space is nothing but it could be a 10 GB space or 20 GB space, whatever that is defined onto your infrastructure, right? So when you run a query and when that query is bringing the data from your actual database to that spool space and trying to process, if that query's storage is more than 20 GB, then it is spool out. Okay.
right.
So we have seen into the legacy systems where the SQL Server, Oracle, your queries become spool out, right? That okay, there is no much resources, right? Because all these Redshift, Snowflake, and everything is built on the cloud infrastructure. That issues we have not seen it. Okay, your queries will might run longer, but they will not spool out because of the space issues and all that, right? So Snowflake will keep those queries in the queues, and as soon as there is a free space or free resources, it will automatically move from the queuing to processing, right? So if you go back to your Snowflake and try to see the different steps where the queries were, first it goes to the queue, and then from queue it goes to processing, and from processing it will go to the execution, and then from execution it will give you the data what you are trying to access. Okay, but we have not seen issues where your queries will not run, but there is always a timeout which you have defined on your infrastructure, right? That okay, there is a time of, let's say 1 hour. Okay, so any queries who is running more than 1 hour, it will always automatically get timed out, right? Because there is no point of running your query to 2 hour or 3 hour, right? So that we always define into your Snowflake that okay, there is always the upper limit of your query should not run more than 3 hours or 4 hours, right? Because that's unnecessary running our queries and resources, right? Because if I'm not able to get the access data within that three hours, then there's no use of the Snowflake, right? Then at that point of time, then you have to understand that okay, do I have to increase the size of my warehouse so that my queries will run faster and then get the data, right? So at that point of time, you have to take a decision.
Yeah. So one question is like whenever this happens, when I'm trying to balance my load on the right, is it that is the approach, or I should also see my schema, how it is developed? Like, is there a fault where schemas are complex and I can simplify it so the pointers are kind of approaching the right schema? Like how that approach is the first step, or this approach should be the first step, that this is the time I need to increase, but decide whether I want to go vertical scaling or a horizontal scaling.
Yeah, that's a good question. I think I think this should be a last step, okay, in your process, okay. But you always define the infrastructure like that, right? It should automatically scale it, okay. Because you don't know when the peak hour is going to come, right? If you understand that, okay, what is the future trend of your data is going to look like, okay. So the first step is always to understand that, okay, how efficiently I'm storing the data, right? So there is a concept of partitioning, right? You should have the data in the partitioned way so that when you're trying to access the data, the queries will access the data quickly. Okay. So those are the other aspects of your system design, which we will talk in the next classes. But this particular part should become a last step, because in horizontal scaling or vertical scaling, there is always a cost associated with your platform, right? Because if you are increasing the size of your warehouse, you have, when you're running the same query on a larger warehouse, for a larger warehouse, the cost will always be higher. Okay. So this is always going to be the last step where you have tried everything, you have sorted your data, you make sure that your data is your table structure, your schema, everything is defined correctly, your partitioning of the data is all happened correctly, your data is in the correct format and all that. Okay, then at that point of time, if you are not able to process your data, then you go back and talk to understand that, okay, if I increase the size of my warehouse, will my queries run faster? If yes, then you go ahead and increase the size, because there is always, as I said, there is always a SLA defined to your data processing. Okay, if you're and that SLA is defined by your business. So if they want a data to be refreshed in the report every 1 hour, right? But your pipelines which you are running is not able to refresh the data within 1 hour, right? Then the dashboard is not refreshing in every 1 hour, right? So that's a breach of your SLA. Okay, so in that aspect, then you go back and assess that, okay, when I increase the size of my warehouse, my data will process within 30 minutes, right? If that's okay, then you go ahead and increase the size of your warehouse.
Okay, and this decision should be done on incremental basis, or it should be like I will do a demo, like I do a pilot.
No, I think it's on incremental basis. Suddenly your size of your data has increased, right?
Okay.
Like I'll give an example that, okay, now currently you are only 100 traffic, 100 users traffic on your website. Suddenly it increased from 100 to 1,000, right? Then your backend infrastructure is not able to handle. Then you increase the size. But the cloud system will automatically scale up or scale down, right? That's the feature of your cloud systems, right? But you have to build your infrastructure in some way, in that sense that, okay, it will automatically scale up, right, based on your traffic of the data, right? So that all decisions happens incrementally. It's not that, okay, I increase to let's say long and I'm pretty sure that it's going to run 1 year or 2 years, right? That nothing is going to happen within 1 year or 2 years. That's not going to happen, right? Because your data might change, your volume might change, right? So you have to incrementally see that, okay, what is the behavior of your data pipelines? Okay, whether the data has increased, whether processing power has reduced, if the SLAs are breaching, right? Then you go back and change all these changes on your infrastructure.
Okay. Got it. So like lot of things has involved when I take these decisions, not only technical part, but
there is always a cost, your SLA to your business, your current situation where you're running these data pipelines, your time, everything comes in a factor. Then you can go and change that, right? Because there is an implication always, right? If you're changing an infrastructure in our organization, the same infrastructure is being used by multiple teams. Okay, so it's not that, okay, you are the only user of that particular infrastructure. Okay, so when there is a need for that change, you have to talk to different teams, saying that, okay, and there will always be communication to different teams that, okay, we are going to make the change into this particular part of your infrastructure, right? Or the current service what I'm using is not able to handle all the situation, right? So I'm introducing a new service over there, right? So that needs to be communicated to every team who is doing that infrastructure, right? So
but
yeah.
The decision saying is of data engineering team or data team.
Yeah, so it is a combination of your data engineer who's using that platform. There is a decision of a data architect who is going to implement those changes, and there is always a business who is going to involve, like the owner of the organization and all that, right? Because they have to pay, and there should be a cost. So whoever is owning that business unit, right? Like let's say in an organization, you could have multiple business units.